Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Stephanie Glenn, your host. I am the Editorial Director at Data Science Central. I'd like to start our event off today by thanking Alation for sponsoring today's event. Alation is a long-time supporter of the Data Science Central community, and we are honoured to have them sponsoring our event today. Today's webinar is entitled Productive Self-Service Data Science at AmFam, to be presented by Alation. Before we begin, I'd like to briefly review the format of today's webinar. Today's event will be 1 hour long. We have two presenters who I'll introduce in just a minute. There will be a 10 to 15 minute Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. I'd also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing and presenting them on your behalf during the Q&A portion of today's event. I'm very pleased to introduce today's speakers, Sean Kappers with American Family Insurance and Raja Perumal with Alation. Sean Kappers is a data engineer with American Family Insurance. He is part of a small team tasked with developing self-service, reusable data pipelines for data science, analytics, and reporting. He enjoys digging deep into the data and tools at his disposal to learn best how to produce the pipelines for consumers. His passion is to make very specific data requests only a few clicks away before users can start getting insights from their data. Raja Perumal is a data architect focused on helping organizations understand, use, and manage their large data environments. He has worked at Alation for over 2 years, helping customers start data catalog programs. Currently, Raja onboards partners to ensure that customers' data catalog investments enable value throughout the analytical architecture. Thanks for being with us today, Sean and Raja. We're looking forward to your presentation. Data science is a core part of American Family Insurance's digital transformation strategy. AmFam has more than 10 million active policies and processes more than 1 million insurance claims a year. And the algorithms the data science team creates are key to enabling underwriters, claims adjusters, agents, and subject matter experts to spend less time on manual processes and low-level decision-making and more time leveraging their experience to impact the business. To create these algorithms, data scientists need high-quality, trusted data. In the past, data engineers have had to build data sets in an old ad hoc manner that was unsustainable for meeting the demands being put on the data scientist. Now, AmFam is leveraging the Alation Data Catalog to enable the data science team to self-serve on curated data, reducing redundant requests, streamlining communication, making valuable knowledge on the data searchable to all data scientists, and reducing onboarding time. In today's Data Science Central webinar, learn how AmFam is driving more productive data science on trusted, curated data with the Alation Data Catalog. Sean and Raja, I'm going to turn it over to you. You can begin as soon as you're ready to go.
All right, thank you, Stephanie. This is Sean, and hello, everyone. I'm starting out here with a couple of polls just to get a sense of where the viewership is at. If you could take some time just to select on the radio button which role best fits you. If you're in a management position, feel free to put your direct reports in there, whatever you think makes the most sense. This will just help me get a sense of who I'm talking to and if I can make any remarks that might fit better with the viewership today. So I'll give you just another moment or two to finish clicking on that. All right. See, we're still flowing in, but looks like we've got a pretty big smattering of different roles within organizations, so that's cool. I'm excited to talk to all of you today. A lot of the slides will be geared more towards data scientists or talking about data science, but I think that you'll find a lot of this will be applicable no matter what your role is. The next one is just trying to understand where you're at in a data catalog journey. So maybe you're actually looking at some data catalog right now, you're trying to implement one, maybe you have one, or nobody's even trying to do anything, or perhaps you just have no idea, and that's totally fine too. So hopefully this will give me a sense of where you're at, and maybe this will also inform some of the questions and stuff we talk about at the very end here. All right, great. Well, it looks like we're pretty all over the map here as well. So we'll definitely be talking about data catalog and how we've been leveraging it here. So like we talked about, this is driving productive self-service data science at AmFam, but so much of what I'm going to talk about today really could go into many other areas within the business, but mostly on the business side, I'm going to be talking to what we've done on the data science side of things. So again, I'm Sean Kappas. I work at American Family Insurance. American Family is just one of the companies in a larger American Family enterprise. You can see some of them over to the right. Many of them are other insurance companies that fill different spaces within the insurance industry where we can collaborate and help one another. But we also have a couple of other companies within the enterprise which are more pure data science and data engineering focused, like HomeGauge and Networked Insights. So we're all over the board. We have a lot of data from a lot of different companies covering all sorts of things about our insureds, the sort of things they insure, telematics data, the geographical weather data, everything in between. So we have a lot of data, but we've really only sort of begun a digital transformation where we are actually being more of a data-driven organization. It was only about 6 years ago that the Data Science and Analytics Lab and the Strategic Data and Analytics divisions were created as areas apart from essentially actuarial departments that were focused on data science and not so much on just kind of gut reactions and people really just depending on their own business acumen and experience, and rather leveraging all the data to actually make proactive decisions going forward. So that started a journey, but is really only a couple of years back where our CEO decided that we were going to acquire HomeGauge and Networked Insights for expanding use of data science, and also the Digital Transformation Office, you'll see DTO in the bottom right-hand corner, was founded. And that was really an important moment in saying we're going to be a data-driven organization. It's not going to just be these smattering of data science projects. We are going to use this data to drive ourselves forward. And so that's continued. The Digital Transformation Office has consolidated some of these spread out groups like the Strategic Data and Analytics Division and DSAL into the Data Science and Engineering Department. We've appointed our first Chief Data Officer, and we've really been working towards how can we achieve process automation, how can we work smarter through data science. So a couple of examples of how we're doing that I'll talk to in this slide here. So we're really just looking to increase business value in one way or another. So a couple of things that we're doing is at a high level, a lot of them are trying to cut down on manual processes, the low-level decision-making that has often been a part of the job roles of individuals who have a lot of business knowledge, but they have some tedious parts of their day that maybe take up 30 or 40% of their time, where they could be using that knowledge to really drive the business forward during that time, but instead they're doing some menial task that isn't something that someone of their expertise really has to be doing. In order to make their time spent more efficiently, we're incorporating data science into a number of these processes. So one example is if you have an insurance policy, it has a term. At some point it expires, and then it's going to get renewed for a further term. During that renewal process, if there has been suspicious or unusual activity on the policy, particularly a lot of claims or reckless driving, things like that, those will sometimes come across an underwriter's desk to determine, hey, should we keep this policy? Should we shift them to a different type of maybe a higher risk type policy? Should we change some coverages? That process in the past was something that was, the thresholds for this were relatively arbitrarily determined. And then, even then, there was much tedious work the underwriter had to do to pull together all the information they needed and then try to make some sort of assessment of, you know, how bad are the issues I'm seeing on this policy, and what should I be, like what do other policies that look like this, what happens with them? So we've been using, our data scientists have been taking all of this data and first of all trying to come up with smarter thresholds for when do these things get referred to the underwriters, so they're not wasting their time looking at stuff they shouldn't be looking at, because it's something that it doesn't need to change, the policy is just fine, but the threshold was messed up. Or also making some predictions about what behaviors, what things happen with other policies like this. Other examples, we've got new chatbots that are using natural language processing to help agents answer questions about policies. Customers will often call up and say, you know, if I wanted to add this coverage, how much is it going to cost? Are there restrictions on this? And these can vary state by state with state regulations. And this means that our product reference manual is rather full of all of this information. The search function for it is pretty rudimentary. If you don't know exactly what to search for, it's that search function by itself it's going to take you a while to hunt down exactly what you want to find. Our data scientists have been using natural language processing with this chatbot to allow the agents to interact and get answers in seconds in sort of a Google search sort of way, rather than having to say, hey, I'll get back to you in 5 minutes, 20 minutes, and I'll email you or call you back. They're able to answer that question right away. And then one of the most important things we're doing with data science is predictive modeling. And this is where we're going to really, I think, drive into the rest of this presentation and see why a data catalog is so helpful. And that's because when you're putting together a training data set for a model, the training data set needs to look exactly like the point in time at which that model would be running in the future. So if when that model runs, typically X, Y, and Z field are not populated, then your training data set shouldn't be populated, or your model is going to be less accurate because it's going to look for things that aren't typically going to be there. An example of this is with our claims processes. If someone gets in a wreck, there's a model that runs to determine, is it likely that this is a total loss or is it repairable? And so based on the information that the claims adjuster collects from someone who calls up and says, I got into a wreck, the model runs and says, okay, what's the best routing? How can we improve the customer experience so that they either know as quickly as possible, hey, your car is not going to be repairable, let's work with you to get a new one, or hey, we can get your car fixed, let's do that as soon as possible so you can get back on the road. Again, like I said, the timing of setting up that training data set to look exactly like what it will look like when the adjuster clicks what they need to kick off that model is very important. That'll be the last point on this slide, but there's just a number of barriers to productive data science at AmFam. So as Stephanie mentioned, I'm on a small team of data engineers that's serving the data scientists. I noticed we have a lot of data scientists, a lot of data analysts. I know that different people enjoy doing different things, but typically I think it seems like not a lot of people enjoy really munging through the minutia of data in order to get the answers that they need. In dealing with all the little quirks in the data and putting everything together exactly how they want to. They'd rather get to analysis a lot sooner. So typically that's where my team comes in, and we're helping the data scientists and data analysts get the data in the format that they want. The problem with this is that if everyone is going through us, we are very quickly the bottleneck. What also gets difficult is that because there are more data scientists and more data science teams than our team can support, it can often have similar requests coming in from different directions, and it ends up with redundant requests being fulfilled for people on accident. And then probably the worst feeling is when business priorities shift for whoever is asking for the data scientist to put something together. And then the data scientists either say, after you've done the work, well, actually, I don't need that anymore. They decided that that's not very important. Or you put something together, and then 3 months later, someone comes back and says, hey, I know I said it was really important that you gave this to me 3 months ago. I didn't have time until just now. Can you answer these questions? None of those things are very good feelings. The other problem that we have in general, and this might be something you can relate to at your company, is that for certain data sets, it can be hard to come by the knowledge you need to really put it together the way you want, because there's only a couple of SMEs. Things are poorly documented. Getting the time of the SME for the underlying data can be problematic, and then you have to have a number of meetings with them to get everything that you want from them. This just all slows down our data scientists' ability to get to finding insights and creating business value. On top of that, then there's just a lot of distrust within the organization between the business and data science. On one hand, sometimes data science is viewed as this magic pill that can solve even the most poorly defined problems. But on the other hand, sometimes the business just thinks that data science is a bunch of voodoo magic powered by some strange amalgamation of linear algebra, and they think that their 20 years in the industry outweighs even what the data is telling them, which can be really difficult. And what further adds to this distrust is that if the business doesn't trust the data that was used to train the model, then they're going to immediately discard the model. And then lastly, we've had problems in the past with how certain data marts have been put together. Those have been given not by my team necessarily, but someone would say, hey, you can just use this data mart. You don't have to go through a data engineer. And then the data scientists have been burned by those data marts not having high data quality. So they don't know, oh, could I actually have used this, or does everyone know that this is actually not very reliable? So enter the need for a data catalog. So what's a data catalog? It seems like a number of you are along this journey already, but if you're not very familiar with one, it's a way of maintaining an inventory of data assets through the discovery, description, and organization of data sets. And then why do you want a data catalog? It's basically something that you want to have a centralized location. And that's what this Gartner quote is getting at, which I'm not going to read for you, but it's a very fancy way of saying if you want to be in the data space, you need to have some way for people to have a standardized way of getting the information they need about the data so that they can get to work. I think that last quote in bold is what's really helpful. You don't want an atlas where basically someone tells you, here is everything you can figure out how to get from point A to point B. They want Google Maps. They want to say, I have point A, I have point B. Give me the directions to get from A to B. So at American Family, we have implemented the Alation Data Catalog, and we'll have a little bit more demo of Alation itself, but I'm going to talk more about our individual implementation of it at American Family in the next couple of slides here. But Alation itself provides one place to find and understand data, which for us increases the efficiency of data science and data analytics and data engineering. It fosters collaboration and reuse and increases trust in the data. So each of these points I'm going to talk about in slides subsequent. So the first one is reducing request redundancy. The way that this has been for the data scientists and for us in the data engineering department is that it's very often that someone comes up with some sort of ad hoc request and they say, hey, can you put together this data set? I want to do some analysis this way, or we want to perform this model to see how new policies are performing. You can have this giant mess of email chains or meetings over and over, or IM chats that nobody knows anything about, or you can have all of that conversation and documentation in one place. And that's where the data catalog has really come in handy for us. What it's turned into is rather than those individual email chains explaining how you get something, or a data dictionary document that's passed from individuals to individuals, or even source control that's only available to a select group of people. We are instead documenting how do I use this data within the data catalog, which is accessible to all of the data users at the company, which means that each time someone answers a question, they're really just building on what's already there rather than starting from square one. What this also means for me is that I'm much more likely to respond to someone quickly if I know that I just have to send them a link from the data catalog saying, here's how you put this data set together, rather than saying, oh, this is going to take me 20 minutes to type up. I'll respond to them on Friday. It makes things a lot better for everyone. The next, and this is a similar sort of point is that this fosters greater reuse of the same queries. Either if someone asks, I talked about earlier, someone asks for something, you do some work on it, and then they abandon it or they forget about it, you have only, quote unquote, helped one person who didn't end up using what you wanted. But if you're putting it in the data catalog where everyone is able to access it, someone else could come along and say, hey, this is exactly what I was looking for. And now I'm able to build on that. Maybe they add some comments or create a new query based on that. This means that there's cases where, especially when those redundant requests come in, the next time someone has a very similar project, they don't need a data engineer. They can come in themselves and say, how would I get this data set assembled? And they're able to follow along and do it themselves. Another way that, or another issue that I talked about was that distrust from the business. They're distrusting where the data scientists are getting their data from. Perhaps you've been in a situation where you put together a report or you're presenting a model and you're showing some metrics in your presentation and you're showing it to some higher up who says, you know, those metrics aren't the same as the ones that come across my desk every month, every quarter. And you have this really awkward moment where it's determined that that there's multiple data sets that have the same metrics, but one is right and one is wrong. And typically, whether or not you're the right one, it's hard for you to overcome that in the midst of a situation where you're presenting. What we're doing with our data catalog is marking for specific important metrics, what is the golden source, what is the correct place to go to get this metric, because there's so many data silos that theoretically promise to provide this metric, but this is the place to go. And so we have a centralized location for that rather than it just being in someone's head. What this means is that our data scientists and our data analysts show up to meetings and the numbers they present are the same to the decision makers who get the same reports coming across their desk. Other things that we're using within the data catalog are the ability to mark data sets as endorsed or deprecated or just have a warning on them. You can also make comments along with this. So this is within Alation. So if I come in and look at this data source here, I see that there's a warning at the top of the screen, and I say to myself, okay, what does that mean? In this case, there's a deprecation. It looks like our data quality scores set by the stewards in this area are below what is expected. So what this means is that, okay, now as a data scientist, I was told I should come in and use this source, but something looks wrong. Now I can immediately go back to the business and say, hey, either you need to get the process that populates this fixed, or I should be using a different source in order to create my model. Similarly, within our data catalog, there's a query tool, and the same thing, if I start building a query, the information about the tables and such that I am accessing are being filled out here as I am typing the query, which means that at that point, I'm able to know, hey, I thought this query looked good, but now stuff is popping up and telling me this is not what I want. Similarly, you could have an endorsement that would say, hey, this is exactly what is recommended for this data set. At the same, and within Alation, we've got the ability to then have messages about similar things. You can either get a notification or you can have a conversation with someone within Alation that then everyone else can follow along with and see, hey, the subject matter expert answered this person's question. Now I know how I can proceed correctly. The last thing that's really helped us with having a data catalog is onboarding. In this world right now, within the data space, tools are constantly changing at your company. I'm sure you're maybe switching from on-premise to a cloud platform. Maybe you're going from, maybe analysts are going from purely typing SQL or maybe just doing some click and drag things to coding, actually using Python or some other programming languages. Those things are often in flux, but the core data for your company is something that is relatively static. How do I actually put this data together? So the way that we're able to make our onboarding process smoother is by having all of the data information within the data catalog, so that in order for someone to then get up to speed on the tools that we're using as a group, they can go in and we say, here's this task. Start with Alation, start with your data catalog, and here's the request. Now use those tools to fulfill that data request. We've been using this within our team to really help people get up to speed on the data side of things, so that they don't have to focus so much on the minutia, but really just how to use the data and how to get used to our environment at American Family. So with all that being said about how we're using a data catalog, I'm going to turn it over to Raj here, who's going to talk about the Alation Data Catalog specifically.
Thank you for that introduction, Sean. Today we'll talk through using the Alation Data Catalog for data science use cases. The Alation Data Catalog is connected to a series of data sources where our customers and their end users can go to answer questions using their preferred data science tools and do analytical exploration to find the best set of data and the most trustworthy set of data to answer those questions. So when I click on this left-hand panel, I can see a series of different data sources where this instance of Alation is connected to, and possibly I can do data exploration. I also see file systems that we're connected to, and finally BI servers where there might already include some sort of answer to the question we're looking for. Let's start by trying to find a data set for diagnosis-related groups in the Northeast. Let's see what happens when we type in one of those keywords into our Alation search engine. Diagnosis-related groups. When I type in that keyword, we have a series of results from all across our analytical environment. The first one looks like a glossary term, and that's the one we'll explore first. But it's also key to see that we get queries, tables. As I scroll through, I see columns and tags, objects from all across our analytical environment. However, I'm going to click on this first result to see if I can get a business glossary term in the form of an Alation article that shows us what our peers and other SMEs in our organization have done to point us to the right data set. And in this case, I found a pretty well curated article. It has a series of reviewers who I can see on the right-hand side. And this article has been approved by Nick Cawley, so I can go ahead and assume that it's accurate. If I need to know more about Nick, I can click on his name and see a profile of what he's been up to get a sense of whether or not he's trustworthy. And in this case, I can see he's an expert of a series of objects and a steward of a series of objects. So I should go ahead and trust that this is the right article to use. And when I look through this business glossary term, it points me to data objects that may contain the right answer, according to at least Nick and the reviewers who wrote this article. And looking at the body, I can see first is a BI report, a BI workbook, looks to be a table. So a series of different data sets and products that I can use. I'll click on this table to open up a table catalog page that Alation creates for every single column, table, schema, report, or file that's in our environment. And we do that by three main steps. The first step is we take a look at the technical metadata that's in the system. So in this case, we'd go to the MySQL environment and extract things like table names, column data types, and the breadcrumb path. We'll also take a look at the technical names, in this case sumtop.drg, and use our natural language algorithm to take a guess on what a possible English name could be. So we'll look at sumtop.drg and fill out summary top diagnosis related groups. And over time, Alation gets better at filling out the English names in this particular dataset as users, business analysts, and data scientists go in and confirm these guesses by the Alation natural language algorithm. The second step is Alation will go through, understand the query logs in this MySQL environment so we can tell information about behavioral patterns. For example, who's using this table the most, whether it's from Alation or any other data set, what columns are the most popular, and also information like filters, joins, lineage, and queries, which we'll get to in a moment. The final step is we encourage the end users, the data consumers and data scientists that are using the catalog to curate this catalog. So we can comment and note items about the data quality if we're not pulling from a data quality tool. We can ask questions about this data using our conversations functionality on the far right. And we can also add a like symbol in the form of a little check mark to say that we endorse this table to use for analysis, to essentially say that this is good data to use. If we want to throw up caveats, we can even put up a warning to note that this data might not be used in some circumstances, like our colleague has put up here and said we need to refer to the PII compliance document before we use this. Or if we want to be a bit harsher, we can even put a deprecation to put a red banner to signal strongly that we shouldn't use this information. I'll click through this. Now that I have the right table for diagnosis-related groups, let's see if we can get information about the Northeast. I can click on columns, and again, this will tell me popularity information about the columns in this table. And here I can sort and understand if I'm going to be doing some sort of analytics or data science on this. It's a very strong case that I'm going to want to use the columns up here that look like they are liked by a bunch of people on our team and also quite popular in real-world usage, as opposed to things like provider name, which has a deprecation on it, or objects like street address and hospital referral region description, which has very little usage. I can click on the Filters tab to understand how users are actually slicing and dicing this table, so how they're using it today based on usage patterns we find in the query log. And in this case, I can see that provider state is actually the top most used column. And I can open up the use value section to see how are people actually interacting with this column. How are they actually filtering on this column? And the key here is to remember that Alation is going to pull from the query logs and show you how people are actually using the data today. So warts and all, you can understand what people are doing with the data. And stewards can go in and other peers can say, I see that you're using this particular definition of the Northeast. However, if I expand this deprecation, I can see that John Thomas has said, don't use this definition. You're always forgetting Vermont. I guess everyone always forgets Vermont when they look at this particular grouping. So as a data scientist, I can say, if I want the Northeast, I should use one of these other endorsed definitions, likely the one that's endorsed by 3 different people. So from here, I essentially know what table to get diagnosis for related groups, how to get the particular grouping of values or grouping of data I need. I can do a bunch of different things from this point. I can click on the Open With button, which will send me to another tool, perhaps one of our data science tools or data wrangling tools we have in-house. I can click on the Query button, which is going to go ahead and open up this filter in our Query tool, which we'll do in a moment. Or I can explore this catalog page further to see if I can get any other useful information. Let's click on the Joins tab, where I'll see how this data set, this table, is used in conjunction with other tables. It looks like the most popular table that this data set is used in conjunction with is a table where someone has labeled DRG lookup. And I can see that, again, this table is under PII compliance. So maybe before I use this particular join or other data set, I need to consult the right glossary or the right policy document. I can click on the lineage tab to see if there's any downstream data sets that I may want to use instead of this sum top DRG data set. In this case, it looks like there's 3 or so different tables that I can use. However, 2 of them have a deprecation on them, signaling that I don't want to use them as someone in our organization has signaled that they're not appropriate for use. I can click on the actual object and see a preview of the catalog page down below. And it looks like the deprecation states that this table is not to be used for analytical purposes. So that's a pretty strong indicator that I shouldn't use that one. I can click on DRG discharges. And this table, again, if I look at the preview, it has some information that looks promising. However, I don't see that many people endorsing or commenting on it. So maybe this will be what I use next if I don't get the right information from my sum top DRG table. Finally, I can look at the queries to see if anyone else has written something that looks like it's something I can use. And just kind of scrolling through these, I see a variety of different queries, but they all seem pretty purpose-built for specific reasons or specific use cases. So I'll go ahead and hit the Compose button to open up this table in our query tool. And from here, we pre-populate the table since I found the right catalog page. And I can click on the schema or the table to see the other endorsements, warnings, and deprecations that are on this object in addition to color coding in the actual query editor. I can type some columns that I'd like to use. Let's type in DRG. And Alation will use that same algorithm that powers our search to make suggestions. And in this case, it's telling us that DRG, that's a column that is very popular to use. And I can go ahead and include that in. And as I keep typing, Alation will keep making different suggestions. Maybe I can include provider state if I want to do that that particular filter. For my where clause, I'll type in where and type in Northeast. And here Alation is again referring to that filter section where I can see there's an endorsed version of the Northeast. There looks to be one or many deprecated versions of the Northeast. So I'll just go ahead and hit enter to pop in the endorsed definition of the Northeast. Now I'm going to run this, so Alation will pass the SQL to the underlying data source with my saved database credentials to go ahead and get results. It looks like our admin has told me that we need to include some sort of filter on this particular query. Since I did it on the state level, I'm going to go ahead and ignore the warning and run that query. And in this case, I have a simple output about 30,000 rows or so. From here, since I want to push this to my conventional data science flow, I could do a bunch of different things. I could save this as a CSV. I can have this run on a regular basis and have it email me the results, or I could download this as an Excel. Alternatively, the final way that I could use this, which is probably most relevant to data science use cases, is I can access this result set based on our Alation Query Results API. So I can directly bring the result set of this query into a Python notebook and then begin my data science workflow right after I have executed and found the right query I want in Alation. So to review, we used Alation to search for a glossary term that has the right information about diagnosis-related groups. It led us to a table that helped us understand where we need to get the data and how to use that data, including what filters to put on it. And in Compose, we were able to write a query using our data suggestions and finally execute it so we can push it to another tool to continue our data science workflow. With that, I will toss it back to Sean. Thank you.
Thanks, Raja. Just gonna have one last slide before I'm going to open it up for some Q&A here, but I hope this presentation's kind of showed you the benefit of a data catalog in general, not just, we're using Alation here at AmFam, but I hope you can see the benefits here of having a data catalog to enable self-service for people. So we see that it's a good thing, except there's one problem. If you have nothing in a data catalog, no matter how nice, no matter how fancy, it's like having a high-end refrigerator with no food in it. Every time you open it up, you're hoping for something delicious, only to find it empty. So different data catalogs and different organizations have different methods of filling out the data catalog. The way that Alation works and the way it works for us really nicely is it's kind of a grassroots thing. There's groups of people who are maintaining it themselves, but there's also kind of the expectation that some of the heaviest data users will be filling in this information themselves. So one way that we've tried to encourage that within my team is to actually make data cataloging a job expectation. So within our group, it's expected that rather than sending ad hoc responses to people or fulfilling ad hoc requests, we'll actually spend the extra time to document things within Alation rather than maybe spend a little bit less time to do it one time. But what my boss really wants us to do is work in a more efficient way, which means that if I know that I'm going to answer this question 7 more times over the next 3 months, I should spend the extra couple minutes to really document it well within the data catalog so that the next 6 times I have to answer that question, I'm instead just pointing them to a hyperlink rather than actually typing out the same email over and over. So that's just one way that's worked for us to really get content out into the data catalog. And there's a number of other ways that our teams have been doing that. Another one is that those who are managing the data catalog, there's a weekly docu-jam where people just set aside some time in the afternoon on a Tuesday, and they just go into Alation and just start filling in stuff that they know is missing that they're a subject matter expert on. So with all that said, thank you. Thanks for your time. I'm going to turn it back over to Stephanie now to host some Q&A.
Oh, Sean and Raja, thanks for that excellent presentation. We'll get started with today's Q&A session. And I want to thank the audience for their participation. We have a great many questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. During this Q&A session, I'll leave up this screen with contact information for Sean and Raja if you'd like to contact them for a copy of the slide deck following today's webinar. Well, let's get started. Sean, the first question I have is, did you experience any challenges in getting data scientists to use the data catalog?
Sure. That's a great question, Stephanie. I think I might rephrase it just because we've got a lot of people beyond just data scientists here. I think it's fair to also say that these challenges could be present for data analysts or even other data engineers. And that's that for us, we had a meta store prior to Alation, but it only had technical metadata. There was basically nothing that anyone could find. And so people kind of had a sour opinion of something like a data catalog. They were hesitant to think that they would actually be able to find any information because technical metadata is helpful if you're in IT, but if you actually want to do something with the data, it's another matter entirely. The way that I think that we found was best to build people's confidence in the data catalog was kind of what I was talking about before. Essentially force them to go into it by answering their questions within it. So if they had asked a question, I would say either, have you looked in Alation? If I knew it was something that's very easy to find with the search function there, or I would say, hey, I've put together this nice Alation page that tells you how you can work with this data set. And so I'd send them a link to that to get them kind of in the habit of going in there.
Okay, thank you, Sean. I love the idea of a docu-jam, by the way. Was that a word you made up, or is that a industry term, docu-jam?
I did not make up the term. I don't know if someone else in my organization made it up or if it's a wider used term. But
Okay,
it is a
I'll
fun
have to
name.
look. It is, isn't it? Okay. So, the next question that came in is, what level of detail is best to put into a data catalog?
Yeah, that's so. Sometimes it's a bit of a touch and go. You do have to know your users. Sometimes every little gotcha in the data isn't that helpful because people are going to uh, quickly get bogged down in the details and feel like there's almost too much there. I think that you want to have enough detail so that people feel like they can get started with something, but not so much detail that they're going to say, like this is way too complicated for me to be able to get started. So typically, the way I think about it is I start with kind of the minimum amount of details and then maybe break up the description within the article to say here, like if you're a really advanced user, here's the additional stuff that you might need, but the I write the initial stuff for the 90% generic use case.
Thank you for that clarification. The next question I have, Sean, is who has access to the data catalog? Is it all analysts, citizen data scientists?
Yeah, so that it's more or less everyone who touches data, at least in an analysis role in the organization. So that's the data scientists, that's the analysts, that's the data engineers, that's also the team that's maintaining Alation and much of the kind of traditional IT. They all have access to it because different people are doing different things, and because it's a grassroots data catalog, like some people are really just going there to get information out. Others are going in there to put in information about data sets they curated, but also the people who are getting stuff out are able to kind of report their findings and share those with other people. So really, in this sort of collaborative environment, the more people, the better, who are able to get in and access it. Because again, if only a small amount of your data people can access the data catalog, then it's no longer a central data catalog. It's you're back to data silos and documentation silos.
Mm-hmm. Makes perfect sense. Thank you. I think we have time for one more question. And let's see. A data catalog could help my team. Do you have any advice for communicating that value to leadership?
Sure. So the trick often, I think, with communicating the value of the data catalog is rather communicating the time lost without the data catalog. If this is, it's kind of the same rule for just documentation in general, right? If you're, and I've said this multiple times, it's if you're spending 20% of your time performing the same task over and over, that's time lost that you could be doing something else. So that means that the way that you want to show that to your bosses, you'd say, or to leadership, you say that, I have this team of subject matter experts, 30% of their time is spent in meetings with people explaining the same things over and over. those people could be providing a lot more. They could be providing 20% more of their time doing something productive without overworking them, by having a data catalog where they could put that information instead of attending meetings. So it's really kind of showing that numbers game of, even an estimate of, I could get back 20% of my people's time so that we could do more projects, provide more business value. And that's where something that seems intangible at first becomes very tangible, where you see how much more productivity there can be for people when you have something like a data catalog.
Mm-hmm. That makes perfect sense. Well, thank you, Sean. Some great answers to some very good questions. And for those of you that asked questions that weren't answered today, we will be sending all unanswered questions to Sean, Raja, and the Alation team so they can follow up with you after today's webinar. I have just a few quick announcements. Please mark your calendars for July the 9th, 2020, and our next DSE webinar, Your Model Will Probably Fail and How to Prevent It. Also, today's taping will be available for on-demand viewing later today and can be found on the homepage of Data Science Central in the webinar tab located at the top of the page. Past webinars are available on demand at datasciencecentral.com. If you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. This brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions, and a special thanks again to Alation for their sponsorship, as well as to our speakers today, Sean Kappers and Raja Parimal, for their insight in today's topic. My name is Stephanie Glenn, and I'm very pleased to have been your host for today's event. I look forward to seeing you all again on July the 9th, 2020. Have a great day.